In this presentation, here is the detailed points which will be helping us to explain the energy production and consumption, or which is I'll be giving you a scientific overview. So let's begin. So in the first slide, actually, the beginning of the energy theory was introduced by the laws of thermodynamics. So the objective, actually, the main objective of the presentation is to provide scientific understanding of energy, its various forms, and the technologies used to harness it. And the importance of understanding this concept are it is crucial for addressing global challenges like climate change, energy security, and sustainability. So let's understand the laws of thermodynamics first. The core principle of the thermodynamics is the energy cannot be created nor destroyed. It can only be transformed from one form to another, which is also called as first law of thermodynamics. Like an example, we can see in a car engine, a chemical energy in gasoline is converted into thermal energy, which is then transformed into mechanical energy. Over here, we can see the conversion of the energy. Well, it is not created. The energy is converted from one form to another form, which tells us about the conservation of the energy. Here in the photo also, in the slide, we can see that the solar energy from the sun is converted into electrical energy by the solar panels, by the solar PV cells. So over here, the energy is just converted from one form to another form. Similarly, the second law of thermodynamics explains the transformations, that is, energy changes from one form to another. And in the third stage, energy is in a closed system, the energy remains constant. Moving on to the next slide, we with energy forms. There are different kinds of energy available: potential energy, kinetic energy, thermal energy, chemical, nuclear, and electrical. So potential energy is nothing but it is a stored energy like a water in a dam, which is kept in at a huge heights. The water at the height reservoir will be having a potential energy based upon the height. Similarly, the kinetic energy, it is an energy of motion like moving a car. And thermal energy, it is a heat energy. Chemical energy, it is the energy stored in the molecular bonds like in gasoline. Nuclear energy, where the energy within atomic nuclei, and similar in electrical energy, where the flow of electrons occurs. So actually the energies over here, interconversion will be happening. So understanding how these forms transform is the key to develop efficient energy technologies, like in solar panels converting light into electricity. So the next slide. Here we'll be learning about the energy transformation, about efficiency and losses. The second law of thermodynamics states that no energy transformation is 100% efficient. Some energy is always lost as the heat. Like for example, in an internal combustion engine, only 25 to 30% of the chemical energy in a gasoline is converted into mechanical energy, while the rest is lost to heat. Over here, the implications are inefficiency. That over here, energy conversion is never perfect. Over here, 100% energy conversion is not done. And also there will be heat losses. And for that, we need an improvement to maintain not 100, we cannot obtain 100% efficiency, but we can like approximately we can obtain to 90%. By enhancing the efficiencies, it is a critical for reducing energy waste and environmental impact. Now fossil fuels. So the formation of the fossil fuels such as coal, oil, natural gas are formed from the ancient organic matter under heat and pressure over millions. It takes millions of years to form. And the extraction of these fossil fuels are coal. We'll be obtaining coal by mining, oil by drilling, natural gas by fracking process. Now combustion. Now these fossil fuels are used to produce the heat and energy, which is later used by the several storage systems, which to generate electricity also. By the heat produced by the after combustion of the coal, it is used to generate steam by boiling the water, and then that steam will be it is mechanically coupled to the wind turbine, and that turbine will be coupled to the generator, which will be generating the electricity. Similarly, combustion, it is a process where burning fossil fuels releases energy, which is heat, but also produces greenhouse gases contributing to climate change. Renewable energy sources. Over here, we'll be having solar energy, wind energy, hydro, geothermal, and biomass. Renewable energy means the energy which is available for all time, forever. Now, solar energy is nothing but it is harness sunlight using PV cells. One. While wind energy it converts wind kinetic energy into electrical energy using turbines. Similarly, hydro energy it captures the potential energy of water in dams. Geothermal energy it taps the Earth's internal heat, while biomass energy it uses organic matter for generating fuel. Now, what are the advantages of renewable energy source? Means they are renewable, means they are highly available, they are sustainable in future generations also, and environmentally friendly. But what are the we have few challenges to counter the for the renewable energy sources. Intermittency, like for example solar and wind, they only depend upon the weather, so based on the climate conditions, several factors, they are only used at particular times. So in rainy season solar energy would be dropping down, so there over here we can use hydro energy. And another, so it depends upon environmental impacts also. Nuclear energy is also another form where we can generate an energy, where nuclear energy contains two processes, fission and fusion. Fission is nothing but splitting heavy atoms, example like for uranium 235 to release the energy used in current nuclear power plants, while fusion means it combines the light, like combining the light atoms such as hydrogen to release the energy. It powers the sun and is being researched for future energy production. So even in the sun, will be sun basically contains huge amount of hydrogen where fusion reaction occurs, so that it will be releasing high amount of energy. But what are the advantages of nuclear energy are high energy output, low greenhouse gas emissions, and the challenges in nuclear energy are nuclear waste management, fission, and technological barriers, which is for fusion. Next, energy storage technologies such as batteries, pumped hydro, compressed air energy storage. These are a few energy storage systems available. In case of batteries they store energy chemically. Like example in lithium ion batteries, basically they are used in electrical vehicles. Pumped hydro, these are the storage system, energy storage system which uses surplus electricity to pump water uphill, releasing it to generate power when needed. Similarly, compressed air energy storage is it compresses the air and stores it underground, releasing it to drive the turbines. The importance of these energy storage technologies are it is crucial for managing the intermittency of renewable energy sources and ensuring a reliable energy supply. Global energy consumption patterns and trends. So in the current state, fossil fuels they dominate global energy consumption, but renewable energy is growing rapidly. So the industrialized nations, they consume more energy per capita, while developing countries like China and India are experiencing rapid growth in energy demand. Over here, we have few trends such as increasing the energy demand due to the population growth and economic development, shift towards the cleaner energy and sources and energy efficiency, and also addressing the energy inequality and promoting sustainable practices. The future of energy challenges and opportunities. The future of energy, they present significant challenges and opportunities. Opportunities include developing innovative energy technologies, improving energy efficiency, and transitioning to a sustainable energy system. Like for an example, advancements in battery technology could revolutionize energy storage and electric vehicles. Similarly, policy changes and carbon pricing mechanisms can incentivize the adoption of cleaner energy sources. There are for future energy challenge the future of the energy, there are certain challenges. There are mitigate climate changes, addressing energy poverty, ensure energy security. While the conclusion of my presentation is that it covers the fundamental principles of the energy, its various forms, and the technologies used to harness it. My key message by presentation is transitioning to sustainable energy solutions is essential for addressing global challenges like climate change, energy security, and energy poverty.